Next we'll see some wave functions. How to find their normalization constants. For example, a wave function psi is equal to normalization constants of wave function. For example, given wave function is psi is equal to a into e power I k y by square root of 1 plus y square. So we have to find a normalization constant a by knowing the probability of finding a wave function in the entire space from minus infinity to plus infinity. It will be 1. So from minus infinity to plus infinity, psi of y comma t mod whole square dy is equal to 1. This is the entire probability of finding that particle or material particle or wave is equal to 1. So by substituting the wave function e power I k y into minus e power I k y become 1 and 1 by 1 plus y square. This is a square into this is a square minus infinity to plus infinity dy by 1 plus y square. So this reduces to a square e power minus e power integral minus infinity to plus infinity 1 by 1 plus y square dy is equal to 1. And if we substitute in place of y is equal to tan theta, y is equal to tan theta, this becomes 1 by secant square becomes cos square theta and d of tan theta, that is secant square d theta. So cos square secant square get cancelled and d theta. So integral minus infinity to plus infinity d theta. So this limits tan pi by 2. So pi by 2 will be infinity. So pi by 2 to plus pi by 2. So that becomes 0 to pi. So 0 to pi d theta is equal to 1. So yes, theta. So this is pi. A square pi is equal to 1 or a is equal to 1 by square root of pi. So if we substitute that into our wave function psi of y comma t is equal to 1 over root pi e power I k y by square root of 1 plus y square. So like this we have to find the normalization constants a. The most frequently used wave function is Gaussian wave function. Like this is 0 to minus infinity to plus infinity. If you see the wave function will be like this. So this is the Gaussian wave function. What is the mathematical formula? E power minus ax square. So if you see what will be its normalization constant? A. This is the wave function psi of x is equal to a into e power ax minus ux square. So by using the same probability e power minus infinity to plus infinity if so this is the kind of Gaussian wave function. e power minus ax square dx in the limits of minus infinity to plus infinity is equal to 1. A square will be there. This is total probability in the entire space. This is the, so if you solve it, a square integral minus infinity to plus infinity e power minus ax square 2ax square. This is 2 here. Ax e power minus ax square into e power minus ax square. So I star will be there. So 2ax square dx is equal to 1. Take it into x. What we'll do is root 2a into whole x square root of 2 into a. So here root 2ax. So for this also we have to make it root 2ax and by root 2ax 2a. So e power minus x square dx is equal to 1. So a square by root 2a e power integral minus infinity to plus infinity, or if you substitute it by z e power minus z square dz is equal to 1. So what will be the value of this e power minus z square dz integral minus infinity to plus infinity? It will be this value will be root pi. So square root of pi. So a square root pi by root 2a is equal to 1, or a is equal to 2a by pi whole power of 1 by 4. And what will be the wave function? Psi is equal to 2a by pi whole power 1 by 4 into e power minus ax square. This is the kind of wave function we'll see. If you know the one wave function and have to normalize it by using the probability.